Hello everyone and welcome back. In the previous episode we introduced the observer pattern and we built the first version using a very simple example with only one variable temperature. That first step was important because the goal was to understand the core idea of the platform the pattern clearly without adding too much complexity from the beginning. Today we continue from that point and in this episode, we are going to make the design more realistic because in real application, we usually do not deal with only one value. A weather station, for example, does not only provide temperature, it might also provide humidity, pressure, and possibly more data later. So in this episode, we will take the same observer patterns and involve the design properly. We will see what starts to become weak in the simple version when the system grows, and then we will improve it using a clear and more scalable design. Also, if my voice sounds a little tired today, it's just because it has been a long day with work and everything else, but I still wanted to record this part while the flow of the series is still clear. So let's continue. At the end of the previous episode, we had a working observer pattern implementation. The structure was simple. Weather station was a subject. Temperature observer was the observer interface. And we had concrete observers like phone display, phone controller, temperature logger. And the update method looked like void update the double temperature. That was perfect for learning the pattern, but now we want to move from a teaching example to a design that looks more like something we could actually extend. Now imagine that our weather station becomes more realistic. Instead of only temperature, it now receives temperature, humidity, pressure. At this point, a very common instinct is to simply expand the method signature. For example, we might do something like update temperature and humidity and the pressure. And yes, technically this works, but the problem is not whether it works. The real question is this good design when the system continues to grow? Because once we start doing this, several things happen. First, method signatures become heavier. Second, every observer is forced to receive all primitives value directly. Third, if later we add another attribute, maybe one speed, or visibility, then the method signature changes again. And once that happens, we have to update the interface, all implementation, and every place where the method is called. So this is where we need a better design. Instead of passing multiple primitive values separately, we introduce one object that represents the weather station. That object will be called weather data, as you can see here. And this object will contain temperature, humidity, and the pressure. So now, instead of sending three separate primitive values everywhere, we send one object. This gives us a cleaner design for several reasons. First, it makes the interface simpler. Second, it makes the code easier to read. Third, it gives us flexibility to evolve the model later. And this is a very important lesson in software design. Sometimes the pattern itself does not change. What changes is the quality of the data model around the pattern. In this episode, I wanted to explain the idea in two steps again. We will look at the wrong direct design with multiple attributes, not because we want to keep it, but because it helps us clearly see the problem. Then We will apply the observer pattern properly using a weather data class, a weather observer interface, multiple concurrent observers, and a weather station that stay loosely coupled. So the goal is not just to repeat the observer pattern, the goal is to see how the same pattern evolves when the example becomes more realistic. Let's begin with the direct approach. We have a weather station, and when it receives new measurements, it directly calls different component. For example, phone display, statics display, alert system. Even if we organize the data better, the weather station is still directly responsible for talking to all these concrete classes. So the data model may improve, but the coupling problem is still there. Here, weather data is already a good improvement, but weather station still depends directly on concrete classes. Then that means if I add a new observer like component tomorrow, I must modify weather station. If I remove one, again I modify weather station. So the architecture is still tightly coupled. To keep the explanation clean, we will create the classes in this order. Okay, just a second. Here we have the simple one. So I will add new package with simple, okay. Let's start now with as I mentioned, so we will create a weather station. Weather data, sorry. So here we will have weather data. As you can see in our design here, we have the temperature, the humidity, the pressure, and we will have the getter. So let's start our class. So private final double and pressure. We will need a constructor. Okay, and we will generate the getter for this class. Okay, the first concrete component, so here is the phone display. White, show, so weather data, it's data, okay, and now we'll have of phone display, the name of the class. Sorry. Okay. Here I have make display look good. Data, get temperature. Okay. And same thing for humidity. And same for pressure. Okay. Very nice. Just a little space here. Job simply to show all current values. The second component is the static display, I think. Sure. Just a second. Okay. Static display, yes. So great. Yeah. This one will calculate the average temperature over time. Say total temperature and just a second. It's rating down is equal to 0. Also the same for the total temperature here. Okay. Double now have the max temperature. And here let me say just here negative entity. Exactly. Okay. And also keep track of the maximum temperature received so far. So here I will start with public void calculate sign calculate that. Okay. So here weather data, data here. Data. Get. Okay. Now we'll have the total temperature, the current temperature, and the rating will be incremented. Okay, just before max temperature, I need to have a control flow here. So I will say if current temperature max temperature, so we will take okay, to make things simple and clear, also for beginners. So we'll have here also the double average temperature, and finally I will add a simple messages to show very nice. So the third component in our design is the alert system. Okay, so I'll add here the class called alert system. Here I will have the method check only. Void check, and we'll take also weather data, past data. Okay. Now, as soon as I set a name of the class, okay, here I have boolean attribute, which is alert trigger, which is false. Now let's start our control flows, which is here if data get temperature is more than 35. Okay, here I'll show this message is like a high temperature alert. Okay, and also I will update alert true. Okay, so the same way for humidity, and also same thing for pressure. Okay, let me say if data point, okay, just data point gets pressure, it's so I will display this message like low pressure alert, low pressure and alert trigger. Finally, now if trigger no alert, no alert. So now now let's create the weather station in the direct style. This is exactly where the coupling appears. So here I'll create weather station. Okay, I will have here an phone display, which is display. Okay, new display. See the others. Okay, and now I'm going to wait set main just click on that view. So pressure. Okay, here I will say weather data is data, take new structure. Okay, and we'll here a message like weather station new measurement received, and I will call the methods of each class. So here I have a problem, I think. There's also on display data. Okay, nice. Now let's create our main method. So class, and here Okay, I'll call the weather station. Station, okay. Station here. We will set measurement. We say here, for example. Okay, I need maybe 2 example enough. So I will delete this one and change the line. Okay, yeah, 5. Yeah, like 65. And enough. So, and here 35. Okay, okay, keep it as it is. So, and so, okay, so, nice. Okay, and now let's test it with a small main class. So, alright. So, as you can see here, new measurement received. The phone display show like the temperature, also the humidity we have here, and the pressure. Static display, average temperature, max temperature, and alert system. And we have here now alert. Here in the second example, what we have new measurement received. Phone display shows everything here, and also high humidity alert and alert system. It works. So now this code is better than the first episode in one way. The data is cleaner because we introduced weather data, but the architecture is still weak. Weather station here, still no concrete classes like phone display, static display, and alert system. So if tomorrow I want to add, for example, a web dashboard, email notifier, forecast analyzer, then I must modify the weather station. That means the subject is still tightly coupled to reaction, sorry, and that is exactly what the observer pattern is supposed to prevent. Okay, now let me introduce the correct design, but before that I want to do a little modification here. I will create a package called run. So, and I will take this design to the run package. Now I will add also a new package here with correct, like we did with the simple design. So here design. Now let me introduce it. So now the structure is much cleaner. The weather station no longer depends on concrete observer classes. It only depends on the interface weather observer. That means now new observers can be added freely as long as they implement that contract, and the weather state is passed through a dedicated object, which keeps the update method clean. Now we implement the final version in this order. Okay, let's start with the weather data. Okay, I will like take things like this. Here I have the weather data. pressure, nothing change. Now we define the contract that every observer must implement, which is the weather observer, which is an interface. So observer. Okay. I try to make this video short. So wait, date. Weather. Okay. Now the phone display becomes an observer. I will change something here. Just a second. So I will here override, and instead of show date, because I will implement here the weather observer. So data here. Sorry, just a second. Okay, I think I have here me. Okay. Oh, okay. See it. Let's. The problem happens when I import the weather data from the wrong package, which is wrong. Okay, so I'll say here date, and also need that as override. Okay. This now the static display also. Yeah. Just a second. Okay. There we have, like, I will delete weather station. Keep it as it is, just here instead of calculate the nights. Date. So I will add here. Nice. Now things are clean. So, and this is a good example of an observer that has its own internal state and the alert system. The alert system. Yes. Okay. It's the weather observer instant. So check result update. Also, I will add here the override notation. Now we refactor the weather station properly. So weather station. Here, I'll delete that. Okay, and here also I will delete this. Here I will say private final and create list of weather observer. Okay, third party list our observers. It's a new array list, and here I will create the register observer. Okay, also the remove observer, and notification, notify observer for sure. Okay, and think I need something. Set measurement for sure. Right. Set, which is I need to add message show. Okay, measurement and notify observer. Very nice. And finally, we create the observers, register them dynamically, and test everything. So I will add here main method. Okay. Let's start with weather station. Weather station. So weather, just observer. I have here the phone display. New display. Display and alert system. Nice. Station now. Weather station point register observers. I will register them three. So I will here. Sorry. Weather station. Okay. Just we need here message display. Okay. I think 2 example is enough. Finally, I will remove like okay, alert system, but and I will that okay 29.0 20 and 5. Nice. Now let me run my program. Here, as you can see, so we have no alert in the first example. In the second example also no alert. Let me try something much like 35 to make the examples different. So let's say just a second. Temperature. Okay. Weather station. System 35. Okay. 35. Skip it. Okay. Just a second. Okay. Tired, sorry. Okay. Now for the first example, no alert. For the second one, we have a high temperature alert. And finally, as you can see here, on the third example, we don't have the alert system. Why? Because we remove this observer. So now let's understand what happens step by step. First, we create a weather station here. Then we create three observer, which is phone display and static display and alert system. Okay, then we register them in the subject when set measurement is called. The weather station builds a weather data object here. After that, it notifies all registered observers. Each observer receives the same weather data, but each one uses it differently. For example, the phone display points all values, the static display updates calculations, the alert system checks thresholds. Then we remove one observer, and after that, and after removal, future updates no longer reach that observer. So now we have a dynamic registration, dynamic removal, loose coupling, and a clear separation of responsibilities. This finally design is better. This finally design is better for two big reasons. First, the observer pattern is applied correctly. The subject depends only on an abstraction. That means the design is flexible and extensible. Second, the data model is cleaner. Instead of passing multiple primitive values, we pass one meaningful object that keeps the interface simple and allows the model to evolve more naturally. And this is what makes this version feel more realistic than the first episode. There is a very important lesson here. Sometimes improving a design is not only about choosing the right pattern, it is also about choosing the right shape of data. In episode 1, the main idea was the observer pattern itself. In episode 2, the main improvement is this. We keep the same pattern, but we introduce a better way to represent and move states through the system. So the architecture and the model both improve together. So now we can compare the two episodes clearly. Episode 1, the goal was to introduce the observer in its simplest form. We use one variable only, temperature here. Okay, that made the concept very easy to understand. Episode 2, the goal is different. The goal is to make the example more realistic. So we introduced temperature, humidity, pressure, and a dedicated weather data object. The pattern is the same, but the design is more mature, and this is actually how many real systems evolve. First simplicity, then refinement. So let's summarize what we learned in this episode. We started from the simple observer design version from the previous episode. Then we asked an important question: what happens when the system grows and one variable is no longer enough? From there, we saw the passing multiple primitive values directly is possible, but it does not scale well. So we introduced a dedicated object called WeatherData. Then we applied the observer pattern again, but this time in a cleaner and more realistic way. And the final result gave us loose coupling, better extensibility, cleaner method signature, clearer responsibilities, and a design that can grow more naturally. That is for this episode today. The goal was not to learn a new pattern from scratch, but to learn how to evolve the same pattern into a better design when the problem becomes more realistic. And that is a very important skill in software engineering, not just knowing pattern by name, but knowing how to adapt them properly. That you very much for thank you very much for watching, and I see you in the next episode.